Right. Good morning. So, yeah, I had a bit of a breakdown yesterday. I was just in a bad mood and I was having like a lot of deep reflections. But let's focus on on what we're trying to achieve here. So, I've been working a ton on the reworked website of Impact because it is called Impact, but of course the npm package name is taken. Also, the organization is taken, but I don't care. I like the name, but it's called Impact, and Impact at its core is reactive contexts for React. So it's basically you have React contexts that are based on React reconciliation. You use the React primitives for state management, which very quickly breaks down and becomes troublesome in state management. But now you have this other type of context for React called a reactive context. And again, the best of both worlds. You use your favorite reactive primitives. I was talking about observable primitives, and it's not like an observable context, observable primitives. But I had to search it up to kind of get my bearings, because when we talk about reactive, we talk about the paradigm, a way of programming, and it's really, instead of being this explicit, like with React, you say like set state, and that makes the component. It's almost like when you do set state, you tell the component to update, kind of. While in this reactive world, we're just making the component observe, right? It's just observing and subscribing to an observation context. And then as you access these different signals or whatever, or observable primitives, whatever you want to call them, it will just automatically like update. I think it's difficult to like pinpoint exactly like how these things differ, but from what I read, it's like observable. We kind of think about the primitives of reactive programming, but it's not wrong to call it like an observable context, because you're kind of observing the observable primitives within the context. But anyways, I think reactive fits better. And then performant and accessible. Reactive primitives are more performant and enables an accessible developer experience for state management. And then nested state management. Provide your reactive state management for specific pages, features, or complex components. Receive reactive props and use any parent reactive context. And then I wrote this presenting Impact thing. Impact is born from the experience of building rich, complex productivity applications. Their complexity is not primarily in data fetching, but managing a dynamic and highly interactive user interface on the client. Reactive primitives has helped us solve performance challenges while keeping us sane expressing all this complexity. At the same time, these reactive primitives have forced us out of React and into a global scope. With Impact, you can use the reactive primitives you know and love and bridge the world of React with your reactive state management at any point in the component tree. That's it. That is the value proposition of Impact. And then you choose. You wanna, we're gonna review. I've made some small decisions. We're gonna call it legend. Legend is like you have legend app, you have legend state, so it's kind of like legend state, but we're just gonna, this is just a tag for it, right? We don't have to say preact signals. It's enough with preact and legend and movex. It's kind of the brand that you're using. Anyways, so here you install either of these packages, where Impact React Signals is the first class experience, and it has like the observable promises and all of that good stuff, the queries and mutations and all of that. But I wanted to show them equal. It kind of looks like we encourage this, and I guess to some extent we do, but it doesn't matter what you use here. The point is, this is your starting point, and then in the learning section now, you go to context, and then we move straight to reactive context. So yeah, by the way, so I've already registered this organization. So we're going to publish these packages shortly, hopefully. And as part of the learning, we have reactive context. And this is the thing, right? At the higher abstraction, we talk about stores, but I want to talk about reactive context. And because like that's the mechanism that allows us to use these like reactive stores or reactive state management or whatever you want to call it. But I think like from day to day, you think about stores, but then having that underlie, it's kind of like React. You understand reconciliation, but you don't think about reconciliation in everyday React work, right? So it's the same here. You understand reactive context, but you think stores. Like React, you think components, and here you think stores. I like that. Anyways, when the React context does not work for us, we have tendency to replace it with global state management. Doing so definitely resolves friction, but we also leave something behind. With Impact, we rather make the React context compatible with the performant and accessible reactive primitives we use for global state management. Impact implements a reactive context. We express this context as a function. It is the same mental model as a hook. You return a public interface for components and other reactive contexts. The difference is that we're not reconciling. This function only runs once. Impact supports any reactive primitive. The reactive context is just a mechanism to bridge the world of reconciliation and your reactive primitives of choice. To get going quickly, Impact provides packages for the most popular solutions. So here we have them. This is kind of like what we highlight. So we have Impact signals where you can see instead of create store, we say create reactive context, because that's what you're actually creating. So we'll have to do some renaming in that. We're gonna publish a Impact reactive context package where we change from store to reactive context internally. It's just naming. There's no change to implementation. Anyway, so here we can see, and this, I think this is kind of cool. So here we can see how it looks like to create a counter with a signal, and you see how it separates the getter from the setter and all of this stuff. And then we have MobX, and this is object-oriented MobX, where you create reactive context from the MobX package, and then here we're just using make auto observable. So like object-oriented MobX is very appealing. Like I just saw this video yesterday with Svelte, and someone was using a class with Svelte. And yeah, looking at this example, object-oriented code is very appealing. But as you'll see as we move through the guide, the learning here, you'll see that it kind of breaks down as you increase complexity. At least for me, it does. I'm not saying that this is like horrible, but you'll see what I mean. But what's really nice about this is that you have this clean class, and then you can use the reactive context to create that class and make it observable. But then there's this other way to use MobX, which is to use it more as a functional store, where you create an observable with state, you have a count, you return that count, and you can increase that count using an action. With Preact signals, it's very much the same. It's just a different primitive. You have the count here, and they use .value, and then you increase that value. And of course, Preact has other things as well. They have like this batching thing, and you can like peek at values and stuff like that. Oh, hello. Thank you. That's nice of you to say. And then we have I never used legend state before. Oh, here we have a typo. Let's see. Reactive context. Let's just do a search for that, because find in folder legend app, and this should be legend state. Just gonna do some very quick changes here. Legend state. Oh, look at this. Yeah, we're gonna do this as we go, so you don't have to watch me refactor all the time. So this was in reactive context. Let's see. Reactive context. And Preact, and then legend. Okay. And then you see legend state. Like, I'm not, like, it's a very interesting API, because they use proxies, but they kind of do it. Don't they have like legend app? Because I thought you could like use assign. I thought you could like just use. Yeah, no, you actually do have to. Anyways, they have, so you can kind of see impact signals uses the solid signature, and then we have preact signals, which has the dot value, and then we have legend state, which has the getter and the setter kind of thing. Yeah, so the interesting thing here is like they use proxies to point into state. So if you have like an object, you can deeply like just dot into the object, as I understand it, but then you explicitly have to do like get or update. Oh, sorry, this should be set. Or set to actually update that value. But when you do get, you actually, so if you have a nested object and you do a get high up, you don't get a proxy. Like you get the actual value. It's very interesting how they mix that. But yeah, but these are just different ways to do kind of the same thing. And this is the whole point. It's up to you what you want to use. And then the hook return from create reactive context has a provider property to provide the context. So this is the same for all of them. And then I just have this. Only implementation in these packages is to configure the props with the related reactive primitive. This is an example from impact signals. So this is what these packages do. They just import impact reactive context and configure reactive context, where the only thing that actually needs to be like configured is the props, so that when these reactive contexts receives props through the provider, it becomes an observable of that package. So MobX gets a MobX observable, Preact gets a Preact signal observable, and so on. And this is how it looks in impact signals, where we just create a signal of the initial prop value, and then whenever you point to props dot, let's say you have a foo prop, and whenever you point to props.foo, it will return the actual value. And whenever React reconciles and there's a new prop value, it will set that value. So that means that if you were to consume this prop in some observation context, setting this new prop value will trigger those observation contexts. That being a component or an effect or whatever. And the props looks exactly the same across these packages. So nested state management, as impact builds on the existing React context, you will be able to instantiate state management related to specific pages, features, or even for each item in a list. The reactive context provider can receive props from React just like normal React context providers. The props are received as an object where each prop returns a reactive primitive representing the value of that prop. This is because React can update the props through reconciliation, as I just talked about. You can use the props with observing primitives like computed, effect, etc., and also expose them from the reactive context itself to be used in nested components or contexts. The hook return from create reactive context can be used in both components and other contexts. So this is more in detail on the props. Excuse me. So here we have like this app store and it receives some props. Now in this scope, we can go and we can use a parent store or parent reactive context, here the global store. And we can consume the props. So in this case, we are consuming a prop as we're instantiating this store, which means that we're just getting the value as it is when the store is instantiated, which is the initial count. But if we, in this case, use an effect and log the user and the initial count, this effect will run again whenever the user changes or the initial count changes. So you can think about these props are the same as the props in React, only that they have a getter. So when you point to props.user, it's an actual getter that returns the underlying observable primitive. And then you can also here create a getter on the store for the user, and it actually returns the props.user. So what can happen here is you might be authenticating, getting a user, and in React you pass this user as a prop to like the app store here in this case. And whenever that user has a change like to some property, that same mechanism that authenticated and gave the user and passed it through React to the App Store provider will have a new user object because some property on the user changed. And it flows into the provider, into the App Store, and is now exposed on this App Store. So you might have like a very nested component that's consuming the user from the App Store. But it actually changed like higher up in the component tree where the user is actually being resolved. So, but the reactivity runs just through the whole thing. And I'm technically explaining it now, but I hope that it just becomes intuitive. You don't really think about it. You just kind of do it. Kind of like how Mobex had this magical thing where, yeah, you were putting these like, as you can see here, like the make auto observable, and you don't really see any reactive code. You just have that magical function at the end. But Mobex was able to kind of, but it just works, right? So you don't have to know about all these reactive mechanisms under the hood, which is kind of, that's the value proposition of Mobex. It's just removing all the reactive indications in the code, which is really cool. Anyways, I see I'm missing an import here. This was nested state management. So this will be, we need make auto observable, needs to be there. So that was, and for Mobex 00, the interesting thing here is that it's a class, right? So the way this works is that we get the props from create reactive context, and then we just pass those props into the App Store class. And here we make them private to the class instance, and then you can just use it. So here with the count is this props initial count, get user, returns this props. It works exactly the same. What's interesting here though is that during instantiation of this App Store, you do actually have access, like this happens synchronously, right? So use global store and clean up and all of this stuff. that's actually available during instantiation of this class, because instantiation of the class is part of instantiation of the reactive context. I would think, yeah, this is just interesting. I'm not sure how people will actually use this, if they would kind of rather pass in dependencies to the, so for example, global store wouldn't be like use global store here. You would rather do use global store here and pass it in. And the same for cleanup. You would rather create a dispose method. You know what? We're gonna do that in this example because it kind of shows better the difference between these two things. So this is the App Store, and then return App Store. And then we have this cleanup where we do App Store. I actually have examples of this other places. Use global store. We're gonna use the global store there. And we're gonna pass the props and the global store. Well, global store and the props. Like that. So we're gonna say private global store. So we're not gonna, let's just move this here. So technically this would have worked, but I'm not sure if it makes that much sense. So we have private global store, we have private props, and then what we're gonna do here, we're gonna have a private dispose effect. And then we're gonna say, not cleanup here. We're gonna do dispose effect equals auto run. And then we're gonna have a disposer, because this is more object oriented, how you would actually do this dot dispose effect. This is how you would normally do object oriented programming. You have these disposers you use. But yeah, and this could be a reaction as well if you wanted to do that. But yeah, I think this is cleaner. But you're kind of starting to see, like now you're kind of starting to see the complexity of the state management that you can do. So the counter example was very simple, it looked super clean. But here you start to see that we have this private disposal. We have to pass in some props. We have a constructor. We run some stuff in the constructor. We have the disposer. Like it just gets more complicated. So if we move now to the other one, you start to see how it could potentially be a better pattern for MobX developers to not have object-oriented, but just use the functional approach, where again, we just use the global store. We create some state where we use the initial count. We have cleanup of the auto run directly here, and we just expose the state like this. So this is much cleaner in my opinion. So yeah, anyways, preact signals. Oh, we have some, oops, these have the wrong import. Let's see. So that will be impact react MobX, MobX and impact react MobX, and then impact react preact. And I guess it's the same here. Impact react legend. Okay, so for preact, it's pretty much the same. Like it's just a different signal primitive. And then legend state, again, what's maybe interesting here is that, well, yeah, you have something called observe instead of effect, but it is the same thing. And maybe what's also interesting here is that we didn't point in preact signals, we didn't point to props.user.value as you would do with count.value, and legend state, you didn't point to props.user.get as you do with the other observables. And the same for impact. We didn't point to props.initial count and called it as a function to get the value. Because you don't need to. It's simpler that we have like the same, because what I just said that these observables needs to do to access the value, that happens in the getter on the props. And now we achieve like the same signature for the props. It doesn't matter what you're using. It does create this implicitness that they are indeed observable. But that's something that you kind of like, it's very isolated. It's the props, right? It's not like randomly stuff around suddenly are implicitly observable. It's just these props. And I think it's just better to have the same API there. Anyways, and then it's another aspect of nested state management is related to typing. Global state management typically defines null values for uninitialized state. With strict null checking enabled, you're likely to find your code having many non-functional if statements to please the type checker. This does not happen with impact because a context is only initialized when its dependent state is available, passed as props. So for example, if your app actually needs a user to operate, you wouldn't have a null user in the state management of the actual app. You would have state management to resolve a user, and then you pass that user to the state management provider in a React component. So you pass the user to the provider that deals with the state management of the actual app, and then you always have a user in that state management. And you won't have any type issues with that. And another benefit of that is the provider that provides the state management with the user can also key, like the provider component can use a key of the user ID, for example. So if the user changes or the user is suddenly undefined, it will actually unmount all the state management related to that specific user, which is really, really awesome. Anyways, and then we have lifecycle. So lifecycle, React has two mounting phases. And it's quite low level, like this learning. But this is the point. Like the impact is designed, as I mentioned in the introduction on the front page. It's designed for teams that are working on like super complex, highly interactive client productivity apps. And you need to understand React and kind of have the experience to at this low level to kind of understand what the impact actually helps you with. It's not something that's designed for someone who's just learning React and wants to build an app and kind of wants to move super fast or something. Yeah. I would expect maybe it does help. I don't know. But it's not intended to be for like people just getting into React wants to build an app. It's for teams who has a lot of friction experience building complex client applications and kind of looks at this and thinks, oh yeah, this is gonna solve some issues for me. Anyways, React has two mounting phases, the render phase and the commit phase. The reactive contexts are instantiated during the render phase as they expose state consumed by the components. When the commit phase has been performed and the components has been mounted, the provider for the reactive context can unmount. Impact allows you to intercept when its related provider component unmounts. This is called cleanup. And again, it's just interesting to see like how things start to play together in the different reactive primitives. So here we have impact signals, we have MobX, and here you can also see we're using the dispose pattern, which is expected in object-oriented programming. Again, we kind of keep the primitives of the reactive context within the actual reactive context scope here, and then we kind of hook them together. Yeah, nothing special there. And with MobX, normal MobX, we do the same thing. Preact signals, we have basically the same. And with legend state, we basically have the same thing. Since our reactive context is just a function scope, we are free to do state management beyond just the state we expose to components. And this is like, Impact is about organizing reactive primitives. And typically when you read about signals, and they're just shoved into a global scope. They're not even organized within any kind of encapsulation. It's just a free roaming global variable, which is, to me, is kind of silly. Like, you want to encapsulate it in some kind of domain, right? So with MobX, at least you make class instances. Like, you have a domain represented by a class, and then you have your observable primitives there. Well, MobX actually makes the class instance an observable primitive, or makes it observable. But then you have these other solutions, which I ponder on. Like, when I see like Jotai and Zustand and all of these, they are, well, not Zustand, because that's a store. I guess Jotai, because they just have these free roaming global atoms. And it must be like solving a friction, because a lot of people are using it and praise it. But I just don't understand. Like, don't you need some encapsulation around it? And also, what I don't understand about... So there are two things. I don't mean to diss on Jotai, because it's definitely super valuable to people. But there are two things I don't understand. One of them is there's no encapsulation. Like, they do have like a store, but that store makes me even more confused because it doesn't work with TypeScript. Maybe I should open the documentation. So you have these free roaming atoms, right? But where do you put them? You just put them in a file. But then you change them from the component. So there's no like encapsulation that allows you to expose the atoms as read to the components, and then you like call functions to actually change them. You kind of choose at the consumption point how you want to use the atom, as a read or write, which is, I guess, flexible. But yeah, in my experience, you don't like, and this is also with Redux and MobX and everyone else, they're like, no, you shouldn't change anything from components. That should be part of the encapsulation of the state. That's where you make the changes. Anyways, and then you have this store where you kind of create something that's not typed at all. And then you just randomly set, you kind of add an atom. Yeah, I don't understand that either. And then, I don't have, it's funny. I don't understand this. How? It seems like the store is just a way to subscribe to. And it's so decoupled. Like, the count atom isn't part of the store. You just have this line here that suddenly makes the atom part of the store. And then you subscribe to, but what if you haven't set the count atom and you try to subscribe to it? Does it just throw an error? Anyways, seriously, I don't mean to diss on Jotai at all. But I just don't understand it. as many people won't understand this thing, right? Anyways, so blah blah blah. You can force a reactive context to remount by using the key property on the provider. For example, you can use the ID of a user to ensure that all state management related to the current user will be disposed. Consider including a suspense and error boundary when providing. Providing. Oh, what's this? Wasn't this? Oh, this was lifecycle. When providing a reactive context, this ensures that the context. Oh, I'm using store. Well, yeah, I'm calling it App Store here. Yeah, when the store unmounts. That's fine. This ensures that the context stays instantiated when using the user or an error occurs during the render phase. So there are two scenarios where React starts the render phase, initializing the reactive context, but might dispose the componentry before going to the commit phase. Like, I had a really hard time figuring this out. I probably didn't read the right article, but this, yeah, it's funny to me that this isn't like more apparent in the React documentation. And maybe it is, I just missed it. Anyways, if a nested component during its render phase throws an error, in this scenario, the reactive context provider catches the error, cleans up, like disposes the whole reactive context, and throws the error up the componentry. This allows any parent error boundary to re-render the componentry, and the reactive context is initialized again. And it is recommended that you add your own error boundary as a nested component of the observable context provider. And so the thing that can so the error is because of something related to the App Store in this case, right? Because it's a nested error from the actual reactive context. So it's very likely that the error is because of something that happened in the reactive context. So you likely want to keep that instance running, and then you manage the error in a nested way. Like, you don't want to dispose of it and then reinitialize it. But that's just how that needs to be done, because if that error is thrown up and we didn't clean up, the user might navigate away from that. Like, the error handler, we have no idea what that parent error handler does, and it might allow you to like move to some other state in the application, which then just throws away the componentry that it tried to render. And we don't know if that happens. There's no hook in React for library authors to know when that happens. So we have to do like a early cleanup. But it makes total sense. Like, this is just deep technical stuff. And then if a nested component during its render phase throws a promise. So this is related to suspense. The reactive context provider includes a suspense boundary that catches the thrown promise and throws an error that you need to add. And throws an error. That catches the thrown promise and throws an error warning that you need to add your own suspense boundary. The reason for this is that React does not provide, as I said, any mechanism to know when a componentry is disposed before the commit phase. In other words, there would be a risk while suspending where the user changes the state of the application and the reactive context provider would not run its cleanup. And this is again, it's fascinating to me that you can't reliably know when you can't instantiate state for a React render and reliably dispose of that state when it's not needed anymore. Because this is the thing, right? It doesn't matter what instantiates that state. Something instantiates state related to a component tree where you want to suspend. And then when that component isn't needed anymore, you want to dispose of the state you instantiated to render that component tree. But you can't do that, because if it's like a promise, you throw that promise, it's a pending promise, and the user navigates away. That component tree never leaves the render phase into the commit phase. So there won't be any component will unmount or anything like that. There's no hooks for that kind of unmount, because it didn't really mount, right? Because it didn't enter the commit phase anyways. And then we have shared context. The interface you return from your reactive context will be available to any component and any nested context. But there are times you want to expose an interface only to nested contexts. An example of that could be a global store that creates an instance of your API. You only want the nested context to deal with this API, not the components themselves. Unlike React's context, where each context is unique and public, Impact implements a shared private context. So this is basically the back channel between the reactive contexts that allows you to expose values, basically, that only these reactive contexts has access to. And this is more something you need with state management, especially if you want to keep this concept of like privacy and public, if that's important. You can use this to handle that. So basically you have like this global store that's at the top of the component tree. You create this API and you want that API to be available to any nested store, but you don't want components to have access to it. So then you can use this context. You just create an object where the keys becomes the injection symbol, meaning that when you want to consume this shared context, you just call it, and then when you access a property, it will actually, under the hood, it will go and resolve that key, that symbol. The symbol is literally the string API, and resolve that symbol and then give you the value, or throw an error if this isn't a valid key. And then we have stores. So a common name for encapsulation of state management is stores. With Impact, you can think about the reactive context as initializing a store. In this article are some recommendations regardless of what reactive primitives you use. So constructing stores, define your store much like a hook, returning an interface to interact with state management instead of UI. When defining state, it is good practice to expose that state as read-only. So here we have the signal, and it's designed to like follow that principle. So you have a getter and you have a setter. For MobX, make observable makes methods into actions where any change to observables outside actions. So this isn't like an actual read-only thing. What the hell was that? Oh. But MobX protects the observables, so that you need to use an action to actually change it. And that's in the functional MobX version. We do the same. Like if you were to try to change well, here we have an actual getter, so it's actually read-only. But in this case, you could technically try to change the count, and MobX actually allows you to change the count as well. You will see it update in the UI, but it throws like a warning that you shouldn't do that. You should only do it from actions. But for Impact, like for Preact, for example, if they're going to follow this principle, they have to be very explicit about that, like returning getters to make the values read-only. It's more of a discipline. And here we have Legend app, and again, it just does the same thing. It's a discipline. And then define any private functions after a return statement. This increases readability of the store as its key features are at the top. So with impact signals, we can just define private functions after the return statement, so that when you read what is this store, you will just get like its state and then the public interface, and then you can dive into like more details. Doesn't really apply here for classes, but again, we still have the action, but we now point to this private increase function. And this is the cool thing about having a function scope as opposed to a class. It's like you have access to everything all the time. You don't have to use the this word or bind anything or do anything like that. You can move functions around, and you still always have like access to all the variables and everything in the scope, which I personally really like. And then we have signal, same thing, legend state, pretty much the same thing. Compose the store using additional function, which you call during instantiation of the store. As they are called during instantiation, they can also consume parent stores, do cleanups, etc. And this just shows that you can like create a counter, which you can look at as its own like reactive context scope. You can define, in this case, signals. You have the private recommendations here. You could like use global store here if you wanted to do that. You could run an effect if you wanted to do that, and so on and so on. And for MobX, you would just use classes, right? And I believe make auto observable does nested. So when it finds a counter here, it dives into the counter and makes it observable. I'm very confident of that. But yeah, nothing special here. It's same. And then we dive into props again. I kind of already talked about props, but this kind of shows a bit more detail how you can use them. Yeah, I probably have to rewrite some documentation. Anyways, stores can receive props. These props becomes observable values inside the store. When React reconciles and updates the prop, the corresponding observable will update its value and trigger observation. So given that we're having this mounting behavior of the store, we pass in potentially a user. It might be undefined. And then an initial count of 10. We can see how this looks like in the different implementations. So for impact signals, you get the you get the props. You can use the initial count, you can use it with derived, you can use it with effect, and you can re-expose it to any nested component or store. And it's basically the same here, but here you kind of see how object-oriented becomes a bit more, I don't know. Anyways, so again, we just pass the props into the constructor. We have a dispose here, so that we pass the props in. Oops, did I forget to call make auto observable? And this is stores. Let's see. There we go. And then MobX, like it's the same, just showing it with the primitives of the library. Cool. And then we have guides, where I want to like free roam, like selling signals. And I just add like a warning that this guide is specifically for the impact signal primitives, where okay, let me run through this one as well. One of the most common things you do in any web application is fetching data from the server and changing data on the server. Under the hood, this is typically based on promises. The new use hook allows you to consume promises directly in components in combination with suspense and error boundaries. This is great, but there is more to queries and mutations than just a promise. So first, simple data fetching. When it is a matter of just fetching some initial data, a signal can manage that. And this is so new, this pattern of being able to handle asynchronous values in like reactive primitives. Like you can say that RxJS has done this for a long time, and yes, it has, but you can't consume, like, RxJS observable is something you subscribe to. It's not a promise that you can observe. So, this is the whole thing about like RxJS. How do you use the current value? Like, why can't you just get the value, right? You always have to subscribe, which has been like a very big mental threshold to understand RxJS. But here we make the promise the actual value of the signal, and then whenever the promise changes its value, in the sense that it moves from a pending state to a resolved or rejected state, or maybe you just update the signal with a new promise, right? It's just an asynchronous value. Anyways, so we just fetch the data. So we return a signal where it's an observable promise. And this data is now an observable promise that can be declaratively consumed in components using suspense or the state of the promise. So this is using suspense. We have data and we use that data. And we can still use it as a promise in stores. So we can call a method, we can await the data, it's just a promise, and use it this way. And then, I didn't have that example. We should have that example. Because that's kind of a big deal. Let's see. The data is now, that can be using suspense. Or consuming the promise status. So that will be kind of the same thing, only that we do this, and then we can say if current data status equals pending, we return loading. If current data.status equals rejected, return error. Or we can say value would be current data. So at this point, TypeScript understands this, right? Because this is a union of status. So if it's pending, now it can only be rejected or resolved. And at this point, it can only be resolved. So we have access to the actual value. Like that. And then also in stores. But then we have refetching data. A pattern popularized by React Query and SWR is to use stale while revalidate. Impact enables this pattern with this query primitive. And I watched this really interesting video yesterday. Oh my god, I forgot his name. Anyways, he talks a lot about React. And there's been, like, the reason React 19 is so delayed is because of a change to how suspense works. And I can totally relate to this, like building a lot of complex productivity apps. And I was so happy to see how eloquently, what's his name? Tanner, the React Query guy, explained how people practically work with data fetching, as opposed to how React wants people to work with data fetching. Like just the fact that React and its recommended data fetching pattern requires you to run a node process to like do server-side rendering and do like data fetching on the server. Like you can use Node as like a middle end, so you still have like an API behind it, but you have to like convince your organization and your team to set up a new Node server to like do data fetching there. And there's so many things that needs to go into that. It's like a huge ass project, as opposed to where a lot of projects are, where you have this API might not be that great of an API, super well optimized to consume data in that specific application, but it's what you have, right? And then you fetch data as you need it in the client, which isn't the most efficient thing, but it's more than enough, right? In practice, it's more than enough, especially for productivity kinds of applications, because it's not about buying products. Like, you need that instant, like how fast things gets on the screen directly impacts how much money you make on the products you're selling. That's not the case for productivity apps. It's perfectly fine to have a tiny bit of loading time as long as the experience after that loading time feels super, super snappy. Anyways, but this is a very interesting pattern. And Impact has a query primitive that's built as an abstraction over signals and the observable promises. So here we go in and we create a query for fetching the data instead. And we get a data query and invalidate data query. So data query has the promise, the current promise of the data, which can be pending, fulfilled, or rejected. And that promise can be updated. So when it's fetching the data again, because you call invalidate data query, then it will go and fetch the data again, create a new promise, but it will only replace the promise when it's done fetching. So the promise doesn't go into a pending state again. It's pending in the background, and then when it's resolved or rejected, then the actual promise updates and triggers the signal. But it doesn't only have the promise, it also has let me read through it. Now components and stores will still consume an observable promise, but they can also access the current state of the query. By invalidating the query, a background process will run the query again and update the promise only when resolved or rejected. So here we can look at the data query state, and that's if it's fetching. No, if it's idle, there's nothing happening with the query. If it's fetching, which is the initial state of the query, because it immediately fetches the data, and then refetching, which is indicating this background process of updating the promise. But then you have the promise itself with its status, just like we looked at. And then you have caching. When you want to fetch data and cache it, you can use a simple record in the store mounted at the level of the component tree where the caching should live. If you want the caching to live only on a single page within a feature or for the whole session of the user, you choose a store that reflects that. So this is lower level than something like React. And you can use React Query with Impact. Like, as I said, the props you pass into a store are observable. So whenever the state of React queries change and you're using those through props inside the store, you're always going to get the updated version. And you can even observe when it changes. Derive values from it, whatever you want. But anyways, if you want to do it with signals or Impact signals, you would create like a record, and then you would have a method for querying an item. And then it will create the query if it doesn't exist, or return the same query if it already exists. And I would imagine, like, if this actually becomes something people want to use, that you would get an abstraction. So you would have a data store where you could declaratively define your different data fetching endpoints, and it will kind of do this stuff under the hood. But the big value here is that you get this. First of all, it's type safe, but you can also observe the promise itself. You don't have all these different ways of like consuming it, like in React Query, and some of them are not type safe. You have this observable promise that you can choose to use with the use hook to trigger suspense. So it's, in some ways it's simpler, but it's also lower level. So yeah, but I'm very, very impressed by the mindset of React Query, especially when we get to mutations, because that's been like a big challenge. I think like doing optimistic updates can seem simple, but the way optimistic updates works here is really, really nice. Anyways, so simple mutation. Just like data fetching, you can also perform mutations with a signal. So here we just create a signal that's undefined, but it can be a promise of void. So when we call mutate, we set the mutation with the promise of doing the actual mutation. In a component or other stores, you can consume this mutation signal as an observable promise. So again, you can just check, do we have a mutation? What's the status? This gives you full control of how the mutation behaves, but just like query giving you a good pattern for handling data fetching, the mutation primitive will give you a good pattern for handling mutations. So one thing is like, what if the mutation is resolved? Do you want to show that? But what if you want to make it undefined again? You kind of want to remove the mutation. It's kind of done. When do you do that? Stuff like that. So optimistic invalidating mutation. Impact provides a primitive called mutation which simplifies mutations, optimistic updates, and refetching. This example considers all the states related to querying an item and changing its title, handling optimistic UI and any errors. So this is kind of putting it all together. And I would also imagine here that you could create abstractions. You could have like a forms store or something that kind of just builds all of this into it and can be more declarative and simplify. But fundamentally, when you consume it in a component, you get access to all you need. So here we have the actual query where we get the item. And we, oh, that's a mistake. Yeah, we should check. So these should not be callable anymore. Oh, it's only that. Great. Sorry. So we create this query of get item, which just fetches the item. And then we have a mutation where we pass in a title. And then we call the put item title. And when that's done, like part of the same promise of the mutation, we invalidate the item query. So when you do the mutation, first it calls the mutation. When that resolves, it calls invalidate item query. And only then, when it's invalidated, meaning it has refetched the item, then the mutation is done, right? And then we just have a signal for managing, updating the title, and we just expose all of this stuff. One thing to note is that when we do mutate the title, we run mutate title, but we also set the edited title to null, so that in the UI it flips from edit mode to normal mode. Okay, so that's basically all the code for doing that, and then we can see how we can deal with a shit ton of complexity in the component. So we go and grab the item store. We have the current item query. And this is a pattern I find that's really nice, is that you have these observable values, right? But you're consuming them at their current state. So using like the current word, like prefix, is a nice way to avoid like naming collisions. So you have like item, like if I had the structured item query here and just called item query, I would have current item query. So item query represents, reflects the value at any point in time, but when you call it, you get the current item query. Anyways, so we have a current item query where we're going to use the promise so that we get the item, and it throws the suspense boundary. But then when that's resolved and we actually render out the item, we go and check the edited title value and if we have a title mutation. So now we want to render this title that's going to be editable. So first we check, are we actually running a title mutation? And if we are running a title mutation, is that promise rejected? And if it's rejected, we're going to state that something went wrong saving the title, and we're going to give it a button, and when you click that button, we're going to run the mutate title function again. And we're going to give it the title of the mutation. So when you have a mutation, you have a promise and you have data. The promise is the actual promise doing the mutation, and data is the parameter you passed in to the mutation. So data here would represent the title, and all this is typed. So we have a mutation, the promise has been rejected, we want to retry it. So we just use the data that we used for the mutation, and we run it again. And then if we don't have a rejected promise, we want to render out the header. We're going to change its style based on the state of the mutation. So if the mutation is pending, we're going to make it like super opaque. Anyways, semi-transparent. And then when it's done doing the pending of the promise and the item query moves into a refetching state, we want to show that, okay, I did a mutation, let's make it less transparent. Because I'm not saying this is a good user experience, but it just shows how you can declaratively handle all these different states related to like doing the initial fetching of the item, doing mutations, and updating the item. So when it's refetching, we change the opacity. And then during the mutation, we show the title of the actual title we passed to the mutation, the optimistic one, right? And then if we don't have a mutation, we're going to check if we have a current edited title. And we're doing this by checking if it's not null. And that's because an empty string, like I can't do no current edited title because empty string is also, sorry, I can't check just current edited title because no string is false. So as soon as you would kind of remove all the characters in the title, it will kind of move away from this with this statement. Anyways, when we are editing the title, we show an input instead where we show the current edited title and we change it. And then when we hit enter, we call mutate title. And mutate title calls the mutation with the edited title and sets the current sets the edited title to null, which moves us basically up here. And then if we're not doing a mutation, we're not editing, we're just going to show the header with the current title of the item. And then whenever we want to edit it, we set the edited title to the current title of the item. So that's managing a shit ton of complexity. And I think very, very often we don't have this. Like you probably experience this. You're using some kind of app and then you just have this bad experience creating, making updates, or something goes wrong and it's not handling all the states. And I think it's because we don't really have good ways of doing it. Which is why I like the React query, this stale while revalidate thing, especially with the optimistic updates. So what I hope is that if you would embrace like query mutation from impact signals, it would make better apps, because it's so much simpler to express and manage all these different states. It kind of leads you on a good path. You don't have to manually think about how you're gonna implement all these states, right? Because you don't have to define these states. You just define your data fetching basically, and it gives you the states. Yeah. Anyways, and then we have the actual impact API. So now it's two parts to this website. It's the impact API and the signals API. So we have create reactive context, creates the hook and relate buffer, right? Create reactive context, just like React, you can have multiple instances of the same context simply by blah, blah, blah. If a nested component throws an error, the reactive context provided will be disposed, and the error is thrown for up to. If you want to recover from nested errors without disposing the context, great. So this is basically from the learning section. And there are two scenarios where providing a reactive context shows an error in development, blah, blah, blah. And then we have like a small little thing here, resolving reactive context, which just explains how the resolving works. We have cleanup, where you import it from any of the packages. Did we? Oh shit. And the same for context. Oh. And then we have the actual signals API, derived, effect, observers, query, and mutation. So all this should be fine. Oh my god, my throat is talking a lot. So what we're gonna do is just update typos. Let's see, what's the time? Oh, we've been at this for an hour. You know what? I'm gonna take a break, and then I'm gonna do the publishing of the packages. But it was nice to just talk through it, and then but yeah, this makes a lot of sense to me. I think we did right by the community. It's much easier to gain value because you don't necessarily want to change the reactive primitives, but it can inspire you to organize those primitives in a different way. Like with MobX, that maybe you want to go functional instead of object-oriented. Or it might just resolve that, oh, I have this huge ass global MobX store. I would love to be able to like mount stores nested in my components because there's certain state management that either relies on certain other state that needs to be resolved and passed in as props, or that you just want to organize the state management around the UI that actually uses it. So that could be a case. And then there is this signals API that has especially these queries and mutations and all of this stuff that might work for you as well. But you're not forced to use it. That's the important part. Okay, that's it for now. Thanks for watching. Bye.